So guys, this is lecture 15, and in this lecture 15 we are going to discuss very important speed time curve. So you can see this is your speed and this is your time. So imagine you have curve like this. So first of all, this is going to be increasing curve. So shape wise, if you see, this is increasing curve. Why we should say increasing? Because you see, when time goes in this direction, so at this point if you draw the slope, at this point if you draw the slope, okay, I'll just do one thing. Students are actually, some people, like some students, they are saying, sir, change the color. So let's do change the color. So you can see at this point if you draw the slope is this. At this point if you draw the slope is this, right? So you see, if this is theta 1 angle, this is theta 2 angle, it is very clear that theta 2 is more than theta 1. Okay, so if you find out slope tan theta 2, of course it will be more than tan theta 1. Okay, it is very shiny. Let's change to the black again. Okay, so best part to write on black is like I think in night time, if you are watching this video, it will not give you so much light on your eyes. That's why mostly I used to prefer black on white, like this. Anyway, so tan theta is more than tan theta 2 is more than tan theta 1, which means this guy is more than this. It means when you are moving in this direction, your slope is increasing. That's why the curve is increasing. It means what? Your speed is not constant. So one more thing, in this case also your speed is not constant, right? In this case also speed is increasing, but in this case you see the second case, in this case your slope is constant. Like you draw slope here, or you draw slope here, or you draw slope here, everywhere you have same angle, but here angle is increasing, and because angle is increasing, that's why it is increasing slope, right? And one more thing, always remember, if velocity is changing, like in this case also velocity is changing, and in this case also velocity is changing, correct? So a separate idea already we have seen, that speed times slope, if you will calculate, then this slope is known as acceleration, correct? But point is, in this case your acceleration is constant because slope is constant, but in this case your acceleration itself is changing. Acceleration itself is changing. It means what? Acceleration is not constant. It means what? It means acceleration is changing. So if you will find out change in acceleration with time, right, of course there is some slope. It is not zero. There is some other value. It means what? When I was teaching you in the beginning, I told you the trick swag. So slope of so I told you to write like this, SVAG. So distance, then velocity, then acceleration, then jerk. So jerk come in the last. It means dA by dt gives you jerk. It means what? In this graph jerk is 0, but in this graph you have some finite jerk, correct? So it means what? Here I will give you one physical feel. You can see if you have a graph like this, in this graph at this time your velocity is this, at this time your velocity speed is this, at this time your speed is this. So this is your speed s1, speed s2, speed s3. Speeds are there, time t1, time t2, time t3. So here if you want to find out slope, what will you do? You want to find out this angle and then find out tan, so that will be your slope. So for that you can use this coordinate and this coordinate, and after that you can apply like y2 minus y1 divided by x2 minus x1 on xy axis, or you can simply say h2 minus s1 divided by v1 minus v2. Sorry, these are your v1, v2, v3 actually, and these are t1, t2, t3. So v2 minus v1 by t2 minus t1. If you do this, then you will be getting your acceleration, correct? But if suppose this curve is like this, then at this point your theta is different, at this point theta is different, at this point theta is different. So in that case, how will you calculate that how fast your slope is changing? It means what? Slope is changing means dv by dt is the slope, and this slope itself is changing with time. Get my logic? So d by dt of dv by dt, correct? So this will be a new property, d2v by dt square. So this we call as, this is nothing but your acceleration. So dA by dt. I hope it's very clear, correct? This is jerk part. Now if you discuss about this kind of graph, suppose this is your speed, symbol is v, and this is your time. In this case, at this point if you draw the slope, angle is this much. At this point you draw the slope, angle is this much. At this point you draw the slope. So continuously when you are moving in this direction, your slope is decreasing. Because your slope is decreasing, what does it mean? Slope is decreasing means speed is decreasing, no doubt. Speed is decreasing, no doubt. Are you sure speed is decreasing? No, speed is not decreasing. At this point you have this speed, you can clearly see. At this time you have this speed, clearly see. At this time you have this speed. So speed is not at all decreasing, speed is continuously increasing. Then why like what is the meaning of this curve? If our speed is continuously increasing, because you can see your speed is continuously, at this time you have only this speed, at this time you have more speed, at this time you have more speed, but I am saying slope is decreasing. What does it mean slope is decreasing? Slope is decreasing, guys, not speed. Slope is decreasing, not speed. Focus here. So if slope is decreasing but not the speed, you have to focus. Slope is decreasing means acceleration is decreasing. Acceleration is decreasing. Now focus here. You have some acceleration here because of this slope, then different acceleration here because of this slope, different acceleration because of this slope. It means what? Your acceleration is not constant. It means what? Just an example. Earlier your acceleration was some 10 meter per second square, then your acceleration was some, just an example, 8 meter per second square, then your acceleration was 5 meter per second square. So these are the new acceleration values. They are new acceleration values. It means what? In the beginning of time your speed was this 10 meter per second, so 10 meter per second per second. Okay, it means your speed was increasing, yes, correct, speed was increasing with 10 meter per second speed. Every second increment was 10 meter, but later increment was there but not 10, it was 8 meter per second per second. After that also increment was there but not like 8, it was only 5 meter per second per second. Okay, so that is the idea of this curve. It means what? Speed is of course increasing, acceleration is decreasing, and how fast or how slow acceleration is decreasing, that you can find out using dA by dt. Anyway, this is not our job to calculate here. Okay, this part I will be teaching you when I will be taking IIT advanced classes. Okay, now this part is not even required for IIT mains and NEET exam. Now this part over. See here, based on this we will solve one numerical. So suppose I am giving you a situation, that situation you have to convert. So anyway, speed time graph over. This was the special speed time graph. Now you also see a similar way velocity time graph. So in case of a speed time graph, you should know it is related to velocity time graph. See here, so I am going to discuss velocity time graph. So how will you discuss this graph? Okay, but before this graph, let's solve one numerical here. So suppose you have this as your speed and time graph. Okay, and suppose, just an example, this curve is parabola. What kind of parabola this is? I'm going to just give you a parabola. This graph is a parabola. Now our job is, with the help of this curve, we have to draw acceleration time graph. With the help of this curve, I have to draw acceleration time graph. So at this point you will be having some slope, at this point you will be having some slope, at this point you will be having some slope. So your slope is constant or not? No, slope is not constant. It means what? Your acceleration is not constant. Means what? Your acceleration is changing. Because your acceleration is changing, then how fast or how slow it is changing. It means what? dA by dt you have to find out. Okay, so if dA by dt you are finding out and that answer is coming as constant, then you will draw this kind of line. Means your dA by dt means rate of change of acceleration with time. So it means AT graph. At this point, what is dA by dt? Slope of AT graph, correct? It means at this point you have slope, at this point you have slope, at this point you have slope, and all the slopes are equal. That's why dA by dt is coming a constant number. At this point angle, at this point angle, at this point angle, right? I hope it's very clear. So this will be your AT graph. But understand, if your dA by dt is not coming constant, in that case this AT graph will also be like this. but this time this will not be this will be a different shape. Okay, but understand, if I will say that I have an equation, suppose velocity is equal to 2t square is my equation. Okay, velocity is equal to 2t square. It means what? If I will, there's a question, velocity is equal to 2t square is given. Okay, draw AT graph, draw AT graph and VT graph, draw AT graph and VT graph. Now let's draw AT graph and VT graph. How will you draw? So to draw VT graph, it is nothing but a parabola. How will it be parabola? I will teach you in mathematics. So you can see this is your V and this is your T. So this is how your graph will look like, VT graph, because here you have 2 power. Now because now you see, now I want to draw AT graph. So what is AT graph? dV by dt, slope of VT graph is known as acceleration. So slope is constant or not? So actually slope itself is not constant. Why? Because you have power 2 here. So at this point to draw the slope, at this point draw the slope. So when time is increasing, your slope angle is increasing. Of course it is not constant with time. Slope is not constant means which property is not constant? Means acceleration is not constant. Acceleration is not constant. It means what? Acceleration. How will you find out acceleration? V is equal to 2t square is there. You just differentiate this, dv by dt. It is going to be 4t, correct? So it means acceleration is equal to 4t. Now what is this equation? This equation you can compare with y is equal to mx, straight line. So that's why it will go like this. This will be your a and this will be your t. It means what? With time, acceleration itself is changing. You can see acceleration is changing with time, right? Okay, now our job is to discuss all important VT formulas, VT graphs. Understand now. Actually, after understanding VT graph and AT graph, we will jump to equations of motion, and we will solve very good examples of equations of motion. So after solving VT graph and AT graph, almost this 1D kinematics properly will get over, and then I will take very interesting previous year selected performed very well numericals, and those numericals will help you a lot. Like clearly, as I said in the very beginning, if you are following this complete journey on YouTube, the complete series on YouTube, you don't have to bother, you don't have to go anywhere else. Immediately after finishing the topic, finishing the chapter, I will start that solution series, right? I will take selected questions that will be sufficient for the practice purpose. Okay, let's meet in the next video.